Hi friends, welcome back to my channel. I am Learning Station and this is me Alvin. In today's video, we'll be going through the lessons in science, basically physics to be correct. And physics lesson number 12. Some natural phenomena. We'll be basically reading through it and I'll explain it basically. And we're also go through the exercises in a following video. So let's get started. And also the PDF to this chapter will be given in the description, and you can also access this same PDF from the NCERT website. So let's get started again. So as I told before, the lesson's name is Some Natural Phenomena. So in this chapter we'll discuss, I guess we can skip over this part because it's just okay, I'll read over this. In this chapter, we'll discuss two destructive natural phenomena. These are lightning and earthquakes. We shall also discuss what steps we can take to minimize destruction caused by these phenomena. So the first subtopic is lightning. So you might have seen sparks on an electric pole when wires become loose. This phenomena is quite common when wind is blowing and the shaking of wires. You might also have seen sparks when plug is loose and in its socket. Actually, I have also seen. You also might have seen this. Lightning is also an electric spark, but on a much bigger scale, though. But in earlier ancient times, the people living at that times did not know or understand these sparks or what they were for. But and they thought they were like the wrath of their god and visiting them like that. So, but now we know the cause of these lightning is because of accumulated charges, which we all know, and we do not have to be afraid because but of the lightning, but we do have to take protective steps from these deadly sparks. These sparks that the Greek people knew about are about these Greek people knew about these kind of sparks as early as the 600 BC. So, like they knew that when amber, which is material or resin, when it is rubbed with fur or hair, this kind of same thing. It attracted light objects such as hair. You might have seen what when you take your woolen or polyester clothes off, your hair stands on end. If you take off these clothes in the dark, you even see a spark and hear a crackling sound. In 1752, Benjamin Franklin, an American scientist, showed that lightning and the spark from clothes are essentially the same phenomena. However, it took about 2000 years for this realization to occur. So in this, there is like a doubt saying the person wonders why it took so much years to realize, and there's an answer by another person. Scientific discoveries are the result of hard work by many people. It can sometimes take a long time, and long time means a very long time. Now we will read about some properties of lightning electric charges, and we will also see how they are related to the lightning in the sky that we have seen. But we'll perform some activities, but I'll just explain them, not perform them. Okay, so when we rub a plastic scale on our dry hair, we all might have seen this. It can attract very extremely small pieces of paper, but not like dust small, but small pieces of paper when you rub them on dry hair for long enough time. And the next subtopic is charging by rubbing. So there's an activity here, activity 12.1. So it says here to take a used ballpoint refill and rub it vigorously with a piece of polythene. Bring it close to a piece of paper and take care not to touch the rubbed end of the refill with your hand or a metallic object. Repeat the activity with small pieces of dry leaf, husk, and mustard seed. Record your observation. So this is basically telling us to do the exact same thing as the plastic and hair thing. So the ballpoint pen refill is about we also rub it with the polythene about we can also rub it with our hair if we want. And like also this like the scale, it also attracts paper, leaf, mustard seeds, etc. I'm not sure about mustard seed. No, and like that. So after that activity, the paragraphs continues saying, when a refill, when a plastic refill is rubbed with polythene, it acquires a small electric charge. Similarly, when a plastic comb is rubbed with dry hair, it acquires a small charge. These objects are called charged objects. In the process of charging the refill and the plastic comb, the polythene and the hair also get charged. Now let's try to charge some other objects that are familiar to you. So we'll just skip over these table. This table, it says we have, we have to try with these two materials for rubbing for with the refill. We have to try with the polythene cloth and a woolen cloth. If it does and does not attract paper, we'll have to tick or yeah, we have to write there and like that for the other column, charged or not charged. And similarly with all the other examples, and the gaps are for for our own materials. And the next topic is types of charges and their interaction. So there's an activity after this, activity 12.3. It says to inflate two balloons, hang them in such a way that they did not touch each other. So we basically just hang them right next to each other, but very close to each other, but we did not make them touch. And after we rub both the balloons with the woolen cloth and release them. So basically at that time we are holding those two balloons so that they don't touch. And then after rubbing both of them, we simply leave them and we'll observe that they basically push away from each other. And let us repeat the activity with use pen refills. Rub one refill off with polythene, place it carefully in a glass tumbler using a stand. And so that. Rub the other refill with polythene, but bring it close to the charged refill. Be careful not to touch the charged end with your hand. Is there any effect on the refill in the tumbler? Do the two attract each other or repel each other? In this activity, we have brought together close together the charged objects that are made of the same material. What happens if two charged objects made of different materials are brought close to each other? So next one is saying rub a refill and place it gently in a glass tumbler as before in figure 12.3, which is this one. Bring an inflated charged balloon near the refill and observe. So as they are like different in this, different in material and etc. like that, so they easily get charged and attract each other. So basically, this will happen if in the balloon example, if we charge one object but not the other, they will also attract. So yeah, there is also another order called the frictional order. I'll talk about that later in this video itself. So as I said, there's also a frictional order which I'll show you right, or I'll show you later. So after this part, I'll show you. So we'll summarize these observations. Yeah. A charged balloon repelled a charged balloon. A charged refill repelled a charged refill. But a charged balloon attracted a charged refill. And And the example I told otherwise is a charged balloon attracted a not charged, non-charged balloon. But does it indicate that a charge on the balloon is of a different kind than the charge of a refill? On the refill, can we say then that there are two kinds of charges? Can we also say that the charges of the same kind repel each other while charges of a different kind attract each other? Is it convention to call a charge acquired by a glass rod when it is rubbed with silk as positive? The other kind of charge is said to be negative. It is observed that when a charged glass rod is brought near a charged plastic straw rubbed with the polythene, there is an attraction between the two. So it is basically saying that when you put a charged glass rod but near a charged plastic straw rubbed with the polythene, the straw is rubbed with polythene, and then there it is said that there is an attraction. So as they are rubbed with different materials, and they are different materials, so they have different charges to each other. So what would you think that would be the kind of charge on the plastic straw? Your guess. Yes, so that you can guess that the plastic straw would carry a negative charge. Yeah, if it is like that, it's correct because the plastic straw, as it is made of plastic, is lower on the frictional order, which I will show you later. The electric charges generated by rubbing are static. They do not move by themselves. When charges move, they constitute an electric current. And I'll skip the next sentence as it is about the previous year. The current in a circuit which makes a bulb glow, or the current that makes a wire hot, is nothing but a motion of charges. So basically, it's a charged particles are basically moving around when there is a current or circuit. A circuit. So the next subtopic is transfer of charges. Charges. Take an empty jam bottle. Take a piece of cardboard slightly bigger than the size of the mouth of the bottle. Pierce a hole in it so that a metal paper clip can be inserted. Open out the paper clip as shown in figure 12.4. Basically, we open it out. Cut two strips of aluminum foil about 4 4 centimeter to 1 centimeter into 1 centimeter each. So we had to make two strips. These are about a precise, small precise measurements, but actually they can be your size, your wish. The size can be your wish, but we can't make them like too big or too small. I guess it's okay. Too big, if we make them too big, they will have the charges that we accumulate won't be enough to move the aluminum foil. Then after that, hang them on the paper clip as shown. Insert the paper clip in the cardboard lid so that it is perpendicular to it. Charge a refill and touch the aluminum foil strips. Charge a refill with it and with the end of the paper clip. Observe what happens. Is there any effect on the foil strips? Do they repel each other or attract each other? Now touch the charged bodies with end of paper clip. Do the foil strips behave in the same way in all cases? Can this be apparatus? Can this apparatus be used to detect whether a body is charged or not, whether an item is charged or not? No. Can you explain why the foil strips repel each other? So the foil strips repel each other because the same charges are going through the material. It is going through. So in this image below, it is shown that a rubbed pen refill is touched to the paper clip, and also as the charges are traveling towards the foil strip, it is the same charge. So basically, they're charged with the same charge, basically the same as rubbing the foil strip, I can say. Okay, so it basically repels each other because they are the same charge. So, and this image below is the model of a simple electroscope. There are much advanced ones than this. The aluminum foil strips receive the same charge from the charged refill through the paperclip. Remember that metals are good conductors of electricity. The strips carrying similar charges repel each other and they become wide open. Such a device can be used whether to test an object is carrying charge or not. This device is known as an electroscope. That's its name. So, thus, we find the electrical charge can be transferred from a charged object to another through a metal conductor, which is basically steel, iron, paper, not paper. Basically, not even a metal. Just we just need a very good conductor, or we can just put a tiny version of ourselves inside. Since human beings are also good conductors of electricity, so if we touch the end of the paperclip gently with the hand after after putting pen refill next to it, if we touch it also, we will also find that this fault strips come back to their original state. And if we repeat the charging of foil strips and touching the paperclip, every time you will find that the foil strips collapse as soon as you touch it. So, so why does this happen? The reason the foil strips lose charge to the earth through your body, we can say that the foil strips are discharged, and the process of transferring charge, the of charge, transfer of a charge from a charged object to the earth is called earthing. So in the yellow part, it is written that earthing is provided in many all buildings to protect us from electrical shocks due to the leakage of electrical current. So this is basically a thing right here. This metal rod is placed here, and there's a copper plate in which there's a wire with a small gap so that electricity just passes through it without touching the building itself. So basically, that's the process of earthing buildings. I'll explain that later. The story of lightning is the next subtopic. It is now possible to explain lightning in terms of charges produced by rubbing. So this is basically the picture of when lightning occurs. So in the top part of cloud, when this charge has enough charges, the top part is positive, while the bottom part is negative. So because the bottom part is negative, it makes a positive charge in the ground below. As there is air in between them, and air is not a good conductor of electricity, the charges does not come together. But when the charges accumulate more and more, it becomes difficult for the air to handle this much charges, and it eventually breaks apart for a small amount of time, and I mean a very small amount of time. And in that, it hits the ground and basically neutralizes itself. And they can also be lightning from cloud to cloud, basically from here to here. There can be small lightning, and we won't be able to hear, we won't be able to see the lightning from cloud to cloud and cloud to earth. We can see them, but cloud to cloud, we cannot see them. We can only hear the thunder produced. So we'll find it out. During the development of a thunderstorm, the air currents move upward while the water droplets move downward. These vigorous movements cause a separation of charges by a process we not yet completely understand. The positive charges collect near the upper edges of a cloud, and the negative charges accumulate near the lower edges. There is accumulation of positive charges near the ground also. When the magnitude of the accumulated charges becomes a very large, the air, which is normally poor conductor of electricity, is no longer able to resist their flow. The negative and positive charges meet, producing streaks of bright light and sound. We see the streaks as lightning. The process is called an electric discharge. So after that, we will read this. Process of electric discharge can occur between two or more clouds or between clouds and the earth. Today, we do not get frightened by lightning like our ancestors did. Now we understand the basic phenomena. Scientists are trying hard to improve this understanding. However, lightning strike could destroy life and property. Therefore, it is necessary to take measures to protect ourselves. So the next subtopic is lightning safety. During lightning and thunderstorm, no open place is safe. Hearing thunder is usually an alert to rush to a safer place. After hearing a last thunder, wait for some time before coming out of that safe place you found. So the subtopic in that subtopic is finding a safe place. House or a building is generally a safe place. If you are traveling by car or by bus, you are safe inside with the windows and doors of the vehicle shut. But and the do's and don'ts of during a thunderstorm are when you are outside, open vehicles like motorbikes, tractors, and construction machinery. Open cars are not safe. Open fields, tall trees, shelters, and parks. Elevated places do not protect us from lightning strikes. Carrying an as these items are not safe because lightning usually tends to hit higher areas above the ground. And carrying an umbrella is not at all a good idea during thunderstorms because the tip of the umbrella usually contains a metal piece which strikes it and then shocks us, basically. And if you're in a forest, take shelter under short trees, not under tall trees. If no shelter is available and you are in an open field, stay far away from all trees. Stay away from poles or other the metal objects. Do not lie on the ground. Instead, squat low on the ground. Place your hands on your knees with your head between hands. So as the picture shows right here on figure 12.6 right here. So this is the optimal position to stay during a thunderstorm to make you the smallest position, smallest target to be struck by lightning. So if you're inside the home or a house, lightning can strike telephone cords, electrical wires, and metal pipes. Do you remember? Lightning is an electrical discharge. During a thunderstorm, contact with these objects should be avoided at all costs. It is safer to use mobile phones that are cordless, other than and cordless phones also, but it is not wise or smart to call up a person who is receiving a phone and through a wired phone, basically like a telephone or landline. Bathing should be avoided during thunderstorms to avoid contact with the running water because water is also a pretty good conductor of electricity. Electric appliances such as computers, TVs should be unplugged. Electrical lights can stay on, they do not cause any harm. And the next one is lightning conductors. Lightning conductor is a device used to protect buildings from the effect of lightning. A metallic rod taller than the building is installed on the walls of the building during its construction. One end of the rod is kept out in the air and the other is buried deep in the ground. The rod provides an easy route for the transfer of electric charge to the ground. So it is basically like a thing, but on a humongous scale. Instead of a hand, there is a metal rod instead of a hand. The metal columns used during construction, the electrical wires and water pipes in the building also protect us to an extent, but do not touch them during a thunderstorm. So basically, it is also saying that during a thunderstorm, it is not that safe to touch the concrete wall, as they also have metal pipes inside them and also water pipes at that time, only at that time. And we should not touch them during the thunderstorm, basically. And this is the electric meter, and this is the top part which is sticking out of the building. And below there is a big copper plate that I showed before. And the next topic is earthquakes. We just learned about thunderstorm and lightning. These natural phenomena can cause large scale destruction of human life and property. Thankfully, these phenomena can be predicted to some level of extent. The weather department can warn about the thunderstorm developing in some areas. If a thunderstorm occurs, there is always a possibility of lightning and cyclones accompanying it. So we get time to take measures to protect ourselves from the damage caused by these phenomena. Another phenomena, there is one more phenomena that we cannot fully predict. We can to some level, but we are not able to predict accurately. And also, it is an earthquake. It can cause damage to human life and property on a huge scale. The major earthquake occurred in India on 8th October 2005 in Uri and Tagnar towns of North Kashmir, figure 12.8. So this is figure 12.8, and it shows the earthquake in Kashmir, northern Kashmir to be exact. Before that, there was another major earthquake in of 26th of January 2001 in the Bhuj district of Gujarat. And this activity says to ask your parents about the huge damage to life and property caused by these earthquakes. Collect a few pictures showing the damage caused by these earthquakes from newspapers and magazines of those days. And prepare a short report on the suffering of the people during and after the earthquake. What is an earthquake? Then after the activity, what is an earthquake? What happens when it occurs? What can we do to minimize its effects? These are some of the questions which we shall discuss now. What is an earthquake? An earthquake is the sudden shaking or trembling of the earth, which lasts for a very short time. It is caused by the disturbances deep inside the earth, inside the earth's core, or the crust, I mean. Earthquakes occur all the time and all over the earth. They are not even noticed. Major earthquakes are much less frequent. Small earthquakes are happening here, now, everywhere, every time there are earthquakes, but they are so minor that we do not notice them. And there are much bigger earthquakes that we easily notice, and they cause immense and very big damage to buildings, bridges, dams, people, property, etc., etc., etc. Like that, on and on, it goes on, and the list of things that can be damaged through these earthquakes are not endless, but they are very big. There can be a great loss of life and property. Earthquakes can cause floods, landslides, and tsunamis and other natural disasters. A major tsunami occurred in the Indian Ocean on 26th December 2004. All the coastal areas around the ocean suffered huge losses. And it says, take an outline map of the world, locate the eastern coast and Andaman Nicobar Islands in India. Mark the other countries around the Indian Ocean which could have suffered damage. Collect amount of devastation caused by the tsunami in India and from your parents or other elders in the family or in the neighborhood. So we'll also skip over these activity explanation. So, what causes an earthquake? In the next box, it said, quote, my grandmother told me that the earth is balanced on the horn of a bull, and when the horn shifts it to the other horn, when the bull shifts it to then another horn, an earthquake takes place. How could it be true? In ancient times, people did not know the true cause of earthquakes, and their ideas were expressed in mythical stories, as the one told by Buju's grandmother. Similar myths were prevalent in other parts of the world. And the other person, which the name is Pahli, it's asking what could cause a disturbance inside the earth. And after that, it says, now we know that the tremors are caused by the disturbances deep down in the uppermost layer of the earth, called the crust, as we have a structure of the earth right here. And in the most centermost area, there is the inner core, and outside there's an outer core, and there's a mantle and a crust, which is the red line over it. So this is figure 12.9. The outermost layer of the earth is not in one piece, but it is fragmented. Each fragment is called one plate, figure 12.10. So these are the earth's plates. There are many more than these pictures are showing. And when they brush past each other, they create a one plate or plate goes under due to an collision, as in figure 12.11 right here. They cause disturbance in the Earth's crust. It is this disturbance that shows up as an earthquake on the surface of the Earth. This is basically a picture of those two plates colliding with each other, and one of them goes under and the other goes above. And the other is about these two plates brushing past each other. Next, box, just Buju asks, if scientists know so much about earthquakes, can they also predict when the next one will strike? Although we know for sure what causes an earthquake, it is not yet possible to predict what and when the next earthquake might occur. And also, it is also said that it's not here, but it is also said that some animals can predict when and where the earthquakes are beginning. And the next box, Bailey is asking, I read somewhere that underground explosions could also cause tremors. Tremors on the earth can also be caused when a volcano erupts or an underground explosion um, is carried out. Most of the earthquakes are caused by the movement of the Earth's plates. Since earthquakes are caused by the movement of plates, the boundaries of the plates are the weak zones where the earthquakes are more likely to occur. The weak zones are also known as seismic and fault zones. In India, the areas which are most threatened are Kashmir, Western, and Central Himalayas, the Northeast and Rann of Kutch, Rajasthan, and the Indo-Gangetic Plain. Some of the areas in the South India are also in the danger zone. The power of the earthquake is measured in a magnitude on a scale called Richter scale. Really destructive earthquakes have a magnitude higher than 7 in the Richter scale. Both Bhuj and Kashmir had magnitudes higher than 7.5, which is very high. And in the next box, it says that the tremors produce waves on the surface of Earth. These are called seismic waves. The waves are recorded on an instrument by the seismograph. It is an instrument which is a simple vibrating rod or a pendulum. It starts vibrating when the tremors occur. A pen is attached to the vibrating system, and the pen records seismic waves on paper which moves under it. By studying these waves, scientists can construct a complete map of the earthquake as shown in figure 12.4, 12.14. So this is the map of the earthquake. This red dot is the focus in which the um, earthquake starts, and right above it, the black dot is the epicenter, right? Which is basically on top of the focus, and the Earth's surface, the green, and the seismic waves of the white ripples that you see. And the waves that you see below the chart, below the model of the seismograph, is a typical seismograph record. So the pen, they can also estimate its power to cause destruction. Like many other scales in science, decibel is also another example in brackets. A Richard scale is not linear. This means that the earthquake of magnitude 6 does not have 1.5 times the destructive energy of magnitude of 4. In fact, an increase of 2 in the magnitudes means 1,000 times more destructive than the energy. 1,000 times more destructive energy. Therefore, an earthquake of magnitude 6 has 1,000 times more destructive energy than an earthquake of magnitude 4. Protection against earthquakes. We know from earlier pages that we cannot predict earthquakes. We have also seen that they can be highly destructive. It is therefore important that we take necessary precautions to protect ourselves all the time. People living in seismic zones where the earthquakes are more likely to occur have to be specially prepared. First of all, the buildings in these zones should be designed so that they can withstand major tremors. Modern building technology can make it possible to make these. It is also advisable to make the structure simple so that it is quake safe. In quotes, consult qualified architects and structural engineers for these projects, and also in highly seismic areas, the use of mud or timber is better than using heavy construction materials such as concrete and iron. Keep the roof as light as possible, and in the case of the structure falls, the damage will not be that heavy. It is also better if the cupboards and shelves are fixed to the wall so that they do not fall. So if it is not fixed, it basically falls when there's an earthquake. But if it is fixed to the wall, it stays right there and only breaks if the wall breaks. Be careful where you hang wall clocks, photo frames, water heaters, etc., so that in the event of an earthquake, they do not fall on people. Since some buildings may catch fire due to an earthquake, it is necessary that all buildings, especially tall buildings, have firefighting equipment in very working order. The Central Building Research Institute, Roorkee, has developed know-how to make quake-resistant houses. In the event that an earthquake does strike, take the following steps to protect yourself. If you are at home, take shelter under a table and stay there until the shaking stops. Stay away from tall and heavy objects that may fall on you. If you are in bed, do not get up. Protect your head with a pillow. And if you are outdoors, find a clear spot away from buildings and with overhead power lines. Drop to the ground. If you are in a car or bus, do not come out. Ask the driver to drive slowly to a clear spot. Do not come out till the tremors stop. So some of it, not all of it, some of it are about the exact opposite of what you should do when a lightning storm is occurring. So like that, I will now show you the frictional order that I told. So this is the frictional order. So the materials that are higher on the order when rubbed with something lower on the order. Now, for example, if I'm rubbing sealing wax, which is right here, wait, sealing wax, which is right here, if I rub it with my hand, for example, I the sealing wax will get positively charged while my hand will get negatively charged. So like that, so we have to for this we have to learn it in the exact order so that we won't get confused. So these materials are wool, flannel, fur, sealing wax, glass, paper, silk, hand, rubber, amber, ebonite, and plastic. So these are the materials. I will also leave these items in the description as well. So this is the end of the lesson, and I will also be not the end. Actually, and we have to have summary of these are the keywords: crust, discharge, just earth's placed plates, earthquake, electroscope, lightning conductor, negative charge, positive charge, Richter scale, seismograph, thunderstorm, transfer of charge, tsunami, and tremor. And there are also some main points over here. So in the next episode, I'll be discussing about the exercises that we will do in the next episode, which will be uploaded very shortly. So friends, if you enjoyed this video, don't forget to hit the like button, and also don't forget to hit the subscribe button. And also if you have any doubts, and also you feel free to type it in the comments below. And I'll upload the exercises shortly in the next, see in the next episode. Until then, it's me, Alvin, signing out.